Hello and welcome to EE 233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our export string 2D array and its similarities and differences to the earlier functions that we have built. This video assumes that you've already watched the video on how to create the export int 2D array, as well as the export double 2D array and export char 2D array. So fundamentally, there's very little difference with this function. As a matter of fact, that's part of the point, is to show the similarities between the four functions. And if you'll notice here, the main difference is that I have a format specifications, format spec of a %s to allow for the array of strings, essentially. So it's a three-dimensional character array. So this is the first time that we've accomplished or encountered something like this. You have a dimension that we would more comfortably think of as a row followed by a column, but then the third dimension, we sort of struggle a little bit. What is that third dimension? And if you think from a geometric perspective, you're suddenly starting to think in terms of the z-axis. Well, that's probably a little bit confusing. Rather, what you want to do is you want to think in terms of like an Excel spreadsheet, so that this is the cell at a given row and a given column. And then this third dimension represents the individual characters within that cell. And so those individual characters for this particular example are going to assumed to be a string. And what that means is that it's going to have an end of string termination character on it. So basically, if this does not have an end of string termination character, then you're going to end up with some problems, because you're not going to be able to tell where the end of the string is. And so as a result, if we make that assumption that it is a valid string that's being stored in a two-dimensional array, we can get away with using the %s for the format spec of both the fprintf that's inside of the nested for loop, as well as the fprintf that resides outside. Now, just a quick reminder, you should go back and take a look at the earlier video. But remember, we have this fprintf that resides outside the nested for loop because our hope is that we use the delimiter for the first m-1 columns, and then the last column gets a new line, which allows for us to put the next row of data on the next line in the file. Once again, we're using results just to track success or failure. This would probably be a great example of where you could look at the number of pieces of data that was printed, or even the number of characters that were printed. And so what you would do here is, inside of the nested for loop, you would simply use your string length function to determine the number of characters in that particular element in the array. So you would have something like results equal to results plus string length of this particular value in the array. And likewise, you would do it as well when you add that last column. The only other thing that you would want to include would be the length of the delimiter. And so you would want to also add the string length of the delimiter, as well as simply adding 1 for the new line, depending on if you want to track that or not. But for this example, we're still going to stick with our results equal to either exit success or exit failure, because in most cases, that is going to be adequate. Now, let's get to the fun of testing this one. So we're going to do this one a little bit differently. We are going to still simply accept a switch from the command line to dictate which function we're going to be doing, but we somehow have to generate that array of strings, and have a little bit different example here. Instead of doing an automatic generation, we're gonna have a little bit of user feedback on this one, or user input on this one. So we still have our else if, and we're still looking at argc equal to 2. And we're going to compare using string compare I. We're going to compare our argv square brackets 1. And the idea then is that it's going to be our export underscore. In this case, if you recall back to our function signature here, this is going to be a string 2D array as opposed to a char 2D array. So it's going to be string 2D array. And if that is equal to 0, then we declare a new 3-dimensional array. It's going to be excessively large, and we'll see why in just a second. So it's going to be array underscore string. And then for the first dimension is going to be n underscore max, and then m underscore max for the number of columns. And then what we want to do is we want to leverage one of our constants over here in our core.h. And in this case, what we're going to do is we're going to leverage our chunk length max. So this is going to be a huge array and arguably an unnecessarily large array. So if in production, you would definitely want to refine this a little bit. So it's going to be chunk underscore length underscore max. And we're just doing this so that it matches then the function signature that we have over here. All right, now, as before, we need an n index. However, though, we are not going to use an m index for this particular example. And so rather than auto-generating this array, we're going to do things just a little bit different. We're going to have one more temporary variable, and we're going to call this one done. And in this case, we're going to initialize done equal to 0 or false. And what we're going to do is we're going to build a while loop. And so while, we're going to have two conditions, while done is equal to false and our n index less than our n max. Now, in order to pull this off, we also want to initialize our n index. We're not going to be using a for loop here since we're using while loop. We do have to initialize it. So we're going to say n index equal to 0. And the only other temporary variable that I'm wanting to use here, and technically speaking, I don't actually have to have it. We can get away without it. We could use a first name and a last name temporary variable. I'm actually going to use them, but then I'm going to show you how that you can get away without it. So we're going to call this a char first underscore name, and we're going to make it the same size as the chunk length max. So it's going to be huge. It's going to be unnecessarily large. And then char, then last name and chunk length max. And we could continue on with some additional temporary variables. Probably the only other one that I would like to have here is maybe some sort of user ID. So why don't we go ahead and create this one as well. So user underscore ID chunk length max. And what we're going to do now inside of this while loop is we're going to prompt the user for the information. And when we get the information, then we're going to turn around and we're going to put it into our array. So we're going to start off with a printf. Please enter a user ID or exit. All right, and we always want to provide the user with a way to get out of a loop. In this case, if they just type in exit, that should be adequate. And then we follow this up with a scanf, and particularly we want to collect a string, and we want to store it now in that temporary variable called the user ID. And you hopefully now see why we need these temporary variables, because we want to capture them. We can evaluate, do a little bit of error checking on them, and so on. And the first thing then we want to do is do a string compare I on the user ID to see whether or not the user of your application typed in the word exit. And if they did, then we simply want to let the user go. Okay, so in other words, we want to continue with the execution of your program, but not collect any more info. And that's just simply a fancy way of saying done equal to true. Under the else branch, what we want to do is we want to collect the additional pieces of information, and that is going to involve the first name. So print f, please enter a first name. And I'm keeping consistent with my variable names here, and just out of habit. There's nothing special about the way that I'm wording this or anything like that. I just like to keep consistent. And we have a scanf then, which is also %s, and we want to store that in the ampersand first underscore name. And then we can do the same thing now with the last name. Now, the benefit of using these temporary variables is that you can do some additional error checking. For instance, that they actually entered in a first name or a last name that met some other credentials, or excuse me, some other requirements, like for instance, the length or the inclusion of numbers, etc. Yeah, you can't, for instance, have a first name like R2D2. Essentially, you could do some additional validation here. But assuming that you're happy with the first name and the last names that they have entered, we now need to get them into the array. And so to begin with, what we're going to do is we're going to assume then that the first column of the array is for the ID. So we say string copy, and we put the array string, remember that's the destination, the first index, which is going to be the row, and the second index, which is the column or the 0th column, we want to put the user underscore ID. Now notice in this particular example that although I have a 3-dimensional array, I'm not specifying that third dimension. In other words, I am putting the entire user ID in that third dimension, so there's no need to specify it. So I only have to specify the row and the column. We could technically put it in character by character if we really wanted to. To continue this, I'm going to do a string copy of our array underscore string. Remember, that's our destination and index. And then for the index equal to 1 column, and I want to put the first name. And I continue with this. So I'm going to go ahead and do then the second column is going to be the last name. Now, the only other thing that we want to do here is we want to increment then our index. So we're going to have something along the lines of n index plus plus. Now, you're about to see this is going to get us in trouble because ultimately we also want to be able to verify our results. So ideally what you would do here is you would have an n count, and then you would leave the n index as simply a indexing variable that you could then use into a for loop. But since we have encapsulated this now into our export function, we don't run into this problem here. Essentially, this while loop initializes however much of our array string as we would like. Now, outside of our while loop, in other words, once we have either entered in 100 names or the user has gotten tired and typed in exit, whichever one of those two comes first, we simply want to say results equal to, and our export string 2D array, we want to pass to it array underscore string. We want to specify however many values were actually collected, which technically is going to be our index variable. And we also want to specify the M. Well, the M in this case, we're actually going to hard code. And why do we do that? Because we were the ones that controlled the location in the individual columns. So we wanted to have the 0, 1, and 2 column. And so as a result, we utilized 3 columns in each one of the rows. And then for the file name for the output, to keep consistent with our earlier examples, we're just going to call this one the string 2D array. We're going to borrow our switch name up there, and we'll specify .csv. And for the last argument, then simply a comma. And then as we did before, a printf, and just tell the user how the application ran. In other words, did it run successfully or did it fail? So results colon %d followed by a new line, and then we just plug in that results value into that placeholder. Now, provided we don't have any mistakes here, let's go ahead and build this real quick. Now, the one thing to note here is this is going to be rather disconcerting or disappointing because we are going to be overwriting our data each time. So each time we test this, we're essentially going to overwrite our output file. So just be aware of that. But if you'll notice here, I do not have a string 2D array.csv yet. I want to go ahead and run my core demo.exe, replacing the switch with string 2D array. And all right, so we seem to have a little bit of a problem here. Let's go back to our code real quick and see what we've got. So a little bit of digging, it turns up that we are simply allocating too much memory, and so we can actually pass some switches to the compiler to fix this, or we can simply reduce the size of these arrays. And as I mentioned earlier in the video, these things are unreasonably large. You would have to have a very specific reason to allocate a 100 by 100 array of 1,000 characters. So rather than do that and look into allocating more memory, why don't we just simply reduce the size of the array? And so if you'll notice in our core.h, we actually have a char count max, which effectively acts as a string length max. So what we're going to do is we're just going to change this here. And you could hard code 20 in there if you wanted to for this example. I'm just going to continue to use my constants, and everywhere I have a line length max, I'm actually going to change over to char count max. And once again, I'm not likely to encounter a user ID or a first name or a last name that's going to be too long. Now, you should also consider to do that in your function signatures. You're going to get a warning if you don't. So what you can do here is you can also change chunk length max to the Char Count Max for now, as well as in your core.c. Now, those last two steps are not required. You'll just simply get a warning. Nothing wrong with a warning in this particular case. It just says that it was expecting an array of a certain size and you were passing an array of a smaller size. So if we go ahead and build this real quick, you can come back out here to the command window, and we're going to go ahead and run our export string 2D array. And this time around, we're actually being prompted for a user ID. We're going to put a couple of them in here. I'm going to start with mine and my first name and my last name. And then we're going to put in J Jones 1, and this is going to correspond to John Jones, and then how about a J Jones 2, and that is going to be Jim Jones. And then we've had enough of this, so we're going to type in exit, and we get our results equal to 0. And then more importantly, if you come over here and drag and drop your string 2D array dot CSV into NetBeans, you'll see that now I have my array populated and, more importantly, exported to a CSV file. So hopefully you found this video useful. It's a couple of different extra features in there, not the least of which is this while loop that allows for you to collect information from the user interactively, but also an unintentional lesson about allocating a little too much memory. And so once again, there is a way to get around that. We are not going to cover that in this video or in this class. And we may cover dynamic memory allocation, which would probably be a better way to go about handling this problem here. So once again, hopefully you found this video useful. If you have any questions or comments, don't hesitate to email me. And thank you for watching.